Hello everyone, this is Divya, Assistant Professor, Department of Computer Science with Data Analytics, Dr. SNS Rajalakshmi College of Arts and Science. So in today's class, we just note on built-in exception. So here the built-in exception programming. So what is built-in exception? So definition for the built-in exception is where the built-in exceptions are predefined errors classes in the Python that is automatically triggered when the specific problems occurs during the program execution, which is provided you the standardized way to handle the runtime errors very gracefully. The purpose is identifying and categorize the different type of errors in the Python programs, and which is used to enable the controlled error handling and recovery also. So which is prevent from the program crashes and which is providing you the meaningful error messages to the developers here. So common built-in exception type is the first one is value error, and then type error and index error, where the value error is which is raised when a function receives the argument of correct type but appropriate value here. That is, if I am raising the function in the receiving the arguments in correct type, but the value will be if it is wrong, which is raises the value error here. Type error, which is occurs when the operation is called to an object of inappropriate type. If it is I'm giving the correct function of the values, if it is the type of the object, it may be the differ, it will be give you the type error. Index error, it is triggered when the attempting to access an index, if it is does not exist in the sequence, it will be show you that index error. So I am given this some of the example here. For int I am just declaring as a hello. So in this case whether type which is correct type but inappropriate value here. So which is raises the value of value error, and which is 5 plus 3, which is also which is giving you the inappropriate type here. Then index value, I am just indexing the value 1, 2. When I raising it, I am used to attempt to access the index number 5. It will be giving you the index error here. So these three exceptions represent the most frequently encountered in the Python programming, which is making the proper handling essential for the robust application. So built-in exception syntax here, first we start with the try block. So which is contains the code that maybe raises an exception. Python attempt to execute this code first. Except block, which is catches and handles a specific exception. Multiple except blocks and can handle the different exception types here. When I go with the else block, which is execute only if no exception were raised in the try block. Optional but useful for the success scenario here. Finally block always execute the final block of whether an execution occurred, perfect for the cleanup operation here. Yes, so step by step exception flow. The program execution begins and I am reading the file safely. The function is called within the file parameter. Next I go with the try block executes. The Python attempts to open the file and read its content into the memory here. So user input requested, the program prompts for the number of line to display and converting the input into the integer here. So the exception monitoring, if any operations fail, the Python immediately jumps into the appropriate except block here. So the error handling, the specific exception like file not found or value error, the permission error can be caught and handled very gracefully here. The success path is if there is no errors occurs, else the block executes, confirming the successful operation here. So finally the final block always runs, which is ensuring the proper resource cleanup and status reporting here. So the flow chart, yes, execute the finally block, which is cleanup continue. So execute try block first, which is run producted code. On exception raised, if it is error occurred or not, the decision will be made here. The match exception type, which is route to the matching handler here. Execute the final block, which is clean up the over then it's go for the continue. So exception hierarchy, the system interrupt, that is system base exception, root of the all built-in exception. The second one is system interrupt, the system exit on keyboard interrupt. Finally, exception branches, arithmetic, lookup and value type or any other OS errors and attributes. So best practices of the exception handling: when we are be specific, when we catch the specific exception rather than exception classes. So this is providing you the unexpected errors and makes the debugging easier here. Order matters. When we place the specific exception handlers before the general ones, Python evaluate the exception block sequentially and stopping the first match. Don't suppress this silently, that is always log or handle the exception meaningfully. Silent failures may be troubleshooting nearly impossible for production of environments. So use finally wisely, that is reserve finally blocks for the essential cleanup operations like closing the file and releasing the logs and terminating the database connection. Finally, rise when appropriate. So re-rise the exception using the rise when you can't finally handle them, and allowing higher level of code manage the error. So summary mind map. So built-in types, there is a value error, type error, index error and a file not found error. The syntax elements which is start with the try and ends with the finally, and the intermediate is except or else. So exception hierarchy, it will be the base exception and exception and specific type here, where the best practices be the specific on order matters and messages and cleanup. So thank you so much.